Our universe is full of spectacular phenomena that leave us in awe. One of the most impressive events that occurs in the cosmos is the supernova. In this video, we will explore what a supernova is, how it happens, and what happens after a star explodes. Hello and welcome to Eccentric Cosmos, where we explore the fascinating mysteries of the universe. First, let's define what a supernova is. A supernova is a powerful and luminous explosion that occurs when a star exhausts its fuel and its core collapses. This explosion is so bright that it can outshine an entire galaxy, and for a brief moment, it can even outshine a whole host of stars. To understand how a supernova occurs, we need to first understand how stars work. A star is born from a cloud of gas and dust in space, and as it begins to collapse, the temperature and pressure inside the star increase. This increase in temperature and pressure creates a nuclear reaction in the star's core, where hydrogen atoms fuse to form helium. In a typical star, the core is supported by the pressure of the hot, ionized gas, plasma, that makes up the star. The heat and pressure are generated by the nuclear fusion reactions that take place in the core, where hydrogen atoms are fused together to form helium. When a star runs out of hydrogen fuel in its core, it can no longer generate enough heat and pressure to keep the core from collapsing. The core begins to shrink and heat up, which causes the outer layers of the star to expand outward, making the star much larger and brighter. This stage of a star's life is known as a red giant. If the star is not massive enough, the core will eventually stop collapsing before it reaches the point where nuclear fusion can occur again. The outer layers of the star will be blown away by the intense radiation from the core, leaving behind a small, extremely dense object called a white dwarf. But if the star is massive enough, the core will continue to collapse until it reaches a critical density known as the Chandrasekhar limit. At this point, the electrons in the core are forced into the nuclei of the atoms, creating neutrons and neutrinos. This sudden increase in density causes the core to rebound, sending a shockwave through the star that causes it to explode in a supernova. The explosion leaves behind a remnant of the star, which can be a neutron star or a black hole. The neutron star is incredibly dense and small, but it has the mass of several suns. A black hole, on the other hand, is a region in space where the gravity is so strong that nothing, not even light, can escape. The explosion also creates a beautiful and complex remnant, which can be seen in the night sky. The remnant is made up of gas and dust that was blown away from the star during the explosion. This gas and dust can be used by future generations of stars, planets, and other celestial bodies. Studying supernovae is an essential part of astronomy. It helps us understand how stars work and how elements are created in the universe. By studying the remnants of supernovae, we can also learn more about how our own solar system was formed. Scientists use computer simulations to model how supernovae occur and how they impact the universe. These simulations help us understand how the shockwave from a supernova can trigger the formation of new stars, and how it can affect the chemical composition of galaxies. Supernovae are rare events, but they are crucial to our understanding of the universe. They remind us of the immense power and beauty of the cosmos and inspire us to keep exploring and learning. Thank you for watching. If you enjoyed this video, please like, comment, and subscribe to our channel Eccentric Cosmos for more fascinating content about the universe.